technically.
Okay.
All right, guys. So basically, there we go. You could just
Present. Right. There you go.
All right. So, okay, I'm going to be looking over my shoulder a bit, but this is going to be my first talk for a while, so bear with me. Okay. So we're going to talk about Dagger 2s, thermosiphons, and coffee machines. Just kidding. I don't know how many of you watched the presentations by Jake Warren or just talks in general. Everyone seems to go to thermosiphons and coffee machines, although what is a thermosiphon? And you end up getting more confused than you need to be. So let's just talk about dependency injection first. Sorry for my ugly slides. I'm not very stylistic. So to get started, you kind of need to talk about inversion control. And a lot of this presentation is going to be my personal interpretation about things. So inversion control, the way that things are described is you don't want to instantiate or basically create objects within your own class files that you shouldn't do. Like maybe you could do like this variable is a new string, blah, blah, blah. But you shouldn't get like, for example, an API and construct it off of things that you need inside your own class file. It should be given what it depends on, which is where dependency injection comes off of. Dependency injection is a software design pattern that implements inversion control for resolving dependencies. That's straight from the wiki, so that's not just my opinion. Okay. Your app and its method constructor signatures are likely to change. That's things that could go wrong without dependency injection. So say I have an application, my app takes, my personal project API, something that's proprietary, but takes, 3 dependencies, and I use it like all over my application. Suddenly the signature changes. Oh, this constructor now takes 3 parameters instead of 2, or, just all a bunch of different various horror stories. Now you got to refactor all your code. You're going to have breaks everywhere. And what if you can't provide that dependency if within that entry point in your app? So that's basically what this slide goes into. As you can see here, just a very primitive example. I have my class. I'm like, oh, hey, I'm my dependency. I'm instantiating within my class file. That's wrong. You kind of want to be given it. So as you can see, inside my constructor, I'm given a dependency. So that's kind of where the inversion control comes in. Now, ways around that is things like factory pattern. Factory pattern, I'm sure most people have heard about here, is basically you have some singleton or static methods which you call to get instances of these classes that you depend on as needed or when you're instantiating new objects. So you could use inversion control where like you have your class get constructor, has a constructor that takes like some API context from, Android, and then you just grab them from factory, whatever. But there's some problems that are wrong with it. There's some issues I have with it, and one of them is a little verbose. And actually, the funny thing is, Dagger 2 has actually a factory pattern in the back. If you actually look at the code, they actually have objects that are called factories. So let's start talking about Dagger, the thing that I mean to talk about. So here, this is what we're striving for. We want to have a point where we could inject on our constructors, inject on our fields, or inject methods. Okay. So as you can see here, if you guys are familiar with how annotations work in Java, you can tag what targets it can annotate. So in this, they make it so you can annotate a field, a class, and a method. Okay. So as you can see, constructor, field, and method. Now, things to note, you can never inject an activity through constructors, right? Obviously, since you don't have, ownership over its instantiation, so you have to rely on field or method injection. All right, so to properly understand Dagger, you kind of have to understand the principle of directed acyclic graph. Okay, so as this little Wikipedia clip says, it's basically, think of any graph that you've had, and when you jump from node to node to node using vertices, you can never end up in a loop. So you can never revisit a node you've previously visited in one direct path, which is more or less what that says right there. Okay, so let's talk about modules. They are kind of like, hey, this is what I have to offer, like your newspaper boys. They have maybe 3 newspapers that they hold with them. I don't know if newspaper boys really do that, but say there's some arbitrary grouping of information or instances or classes, whatever, that they provide. So just think of it, when speakers talk about modules, one of the things that I feel like they always skim over is a module is some arbitrary class which represents some kind of layer in your application. So I'll get to that later what I mean by layers, but in this case, this is the actual implementation detail of a module. So you could perhaps have like a network module, or you could have a data manager module, or you could have your some API. It's completely arbitrary, and the idea here is the less modules you have, the less kind of instantiation work you might have. So this is the actual syntax. You create any class, you tag the module annotation on the root level, and then you say what it provides. So basically, it's like, hey, this right here provides my class. This is completely, it could be called the JK. It doesn't matter. It just knows that it returns a my class, which is what's important for the annotation processor of Dagger 2. So this is just for readability, right? So you tag it with module, you tag what you want to provide to other things outside this module, okay? And if you guys notice right here, this method right here takes my dependency, which is provided right here. So something that module that the annotation processor does, it's aware of dependencies that it can provide within its own module, right? So if this module provides something, other methods that provide other things can take those, right? So that's kind of important to remember. Because, yeah, go ahead.
Sorry, so is it a rule of thumb that you want to have your dependencies in your module be, you don't want to have like a dependency from another module?
Well, that's where I get at is like relatively like arbitrary groupings. You will say like I personally like to organize it. I'll have like 3 maybe like root level modules. So I'll have like a network module, a like system module for threads or for my context, and then I'll have a third one for like APIs or like data management.
So I want to make them as like
Focused, but they could depend on each other within the module, but they don't have to, right? This is just like some arbitrary example where it might depend on it, right? Which is something I'll get into later in this app when I give you a concrete example. So what are components? Now this is the thing that I find the most misunderstood thing about Dagger. So everyone kind of like, oh, okay, I get it. Modules, they provide things, all right? So where do components come in? Well, they're kind of like the guard, okay? They stop things from being like, they basically prevent provided objects to escape the context of that module. So right now, how I showed you how my dependency could go into my my class. Well, with component, as soon as you exit the scope of that module, other modules in your graph, unless they include that module, which is something I'm not going to get into because I don't like that syntax, will not have access to it. Okay, and so this is I'll continue on. This is like the DAG, the directed acyclic graph that I was going to talk about. So you have this component tag on top of your interface, and you tell what its module is. So in this case, my module class, right? And it literally said, and injection means that anything that its dependencies, so like anything that is inside the module can provide, will be injected into this activity. So I have a field labeled, with add inject, and it takes a type of my class or my dependency. It could be injected with that, okay? So does that make sense to you guys? Or did I leave someone behind? Oh, okay. So the module provides my class and my dependency, right? And the reason why I asked you is this is important to really grasp before we move on. This right here says that it has access to these, and therefore anything that we inject, so for example, I have an injection method that takes an activity, will have access to things from my module, okay? So that's what
the activity has access to everything in my module.
Yes, when it gets injected.
Okay.
So now we're gonna get into building bigger DAGs in a moment, but for now, what you have to remember: my modules, their objects are exposed via components to anything outside the graph. Does that make sense?
It does. When you so if you had modules equals my modular class, maybe another module there, the activity would have access to both modules.
Yes. That's why you could have as many modules as you want, which is what I actually do. I usually have like 3 modules, like I said, and then I have a base component, which takes all 3, right? And is like application scope, right? So for a lifetime of my application, those objects are provided.
Okay.
Okay. So does this help, guys? Okay, now I'm going to get into how I represent DAGs in my little slide. Okay, so right here, this is the way I like to visualize what I'm talking about. See this green line, this green box? This is my module class, and these are things that it provides, right? And arrows represent dependencies between things. So as you can see, my dependency, my class has a dependency on my dependency, okay? And once we exit the scope of this class, we have a component which feeds into, say, another class or what have you. So any dependent component or injectable object has access to exposed return parameters from this component or any component that it depends on. So this component has access to its direct modules members, right? So like the my dependency, my class. But what if this component is pointing to another component, which is where people get lost again? Well, those things can only be exposed to anything outside. So basically, the best analogy I can give you is I'm standing far from something, right? Like say I'm standing here and I'm looking at the window and there's like a quarter, but I can't tell if it's a quarter or a dime. And so I'm a component and I depend on another component to tell me if it's a quarter or a dime, right? But in order to do that, that component has to have a method which is like is quarter or dime or whatever, okay? So when the component has dependency on another component, the dependent. Yeah, I know this is getting really complicated. It's just, I'm trying. Okay, so I'm just going to kind of start showing you concrete examples because I feel like I'm starting to lose some people with arbitrary things. Okay, so we're going to build out Tweeter application. We're going to require a fake OKHTTP. We're going to have a fake retrofit, and we're going to have a fake local data cache and a fake Tweeter API. Everything's fake just so it's highly readable and, no issues there. So here we have our OKHTTP client, makes a request, returns a UUID, right? Completely random, it's like, hey, this is some data that I got from the internet, Here we have a retrofit, which, retrofit's the type safety thing, but like for this example, it's just doing some parsing, right? Some arbitrary parsing of the data that the OKHTTP client did. But as you can see, I have a dependency on OKHTTP right here. Okay, don't worry about the main scheduler. That's Rx Java stuff, so I'm not going to dive into that. But as you can see, already I have a dependency on my OKHTTP. So next step, local data cache. Well, I can fetch now data from my fake internet using my fake OTP and retrofit. But what if I want to cache responses? Okay, so I have a fake local data cache, which basically whenever I get a tweet, I save it to an array list. And it takes a context to have a dependency on application context, okay? I don't do anything with context in this situation, but I'm just showing you how you can build up dependencies, right? Because normally you do need context for writing to shared preferences or what have you. So this is my Tweeter API. I'm going to try to skirt around the fact that I use RxJava here. But basically what I'm doing is I'm taking retrofit and a cache, and whenever I get a tweet from my network, after I get the response, I prepend some user tweeted and that random response. So it'd be like some user tweeted like 1, 2, 3, 4, 5, 6, 7 or whatever the random ID is. Okay. So this fake setup makes sense. I think it's pretty simple. Yeah. Anyone lost before I move on about how? Okay, good. Now notice this right here. This is where kind of dependency injection or Dagger 2 comes in. I marked this as injectable, the add inject on its constructor, okay? So it takes a retrofit instance, a cache instance, and once again, a main scheduler. I'm trying to go over this. I have like a GitHub about all this stuff, so I kind of like dissected it and tried to make this digestible in a presentation. Exposing context. So whoops. This is kind of where we'd start with building out our dependency injection tree, our DAG, okay? We're going to start with just having a basic module which exposes the application. That makes sense, right? Once again, module, what it provides, right? But the constructor takes an application, okay? So now when you later on when you build the DAG for later use, you need to have you need a constructor that takes an application. Sorry, let me rewind. You need the application to be passed into this constructor in order to make an instance of this object, so that way it can provide an application, okay? Does that make sense? Okay? So right now, this is how our DAG is starting to look. We have our application module, and we have what it provides. Remember how I showed you to interpret it earlier? Okay, local data module. So this is where our local data cache comes from. Like, once again, very concrete example. But as you can see right here, it's taking an instance of the application, right? Well, how does it get it? Well, it gets it through being linked by a component. So even though this is a different module, I'm going to have this module and the previous module all tied together by one component. So as you can see here, provides module. Okay, very self-explanatory, I hope. Then we go to network module, which provides OKHTTP and retrofit. Remember how we had my dependency, my class? Well, this is like my dependency. This is my class. Once again, this is available to this within this context of this module. Okay, so it provides module. I'm reinforcing this, drilling it in. Okay, so let's start with tying it together. Step 1, application component. So for arbitrary reasons, I made 2 components just to help drive it in, how to do dependencies between components, not just modules and components. We have an application component which exposes an application, which is what I was talking about. So now any component that depends on this component has access to its application. Because remember, this right here tells it that this has access to application. But anything else outside of this component does not have access to application. So in order to make that possible, I do this. So now anything has access to application. Does this make sense? Once again, it's like a guard, right? It's like you guys can go here, but maybe you can't go to other things. Okay? Yeah, go ahead.
So if you hadn't put that line in your application, get application, even though they would have had access to that module, that component, whatever else was in that module, they would have had access to the application.
Yes. So if I had like other types that I provide there, if I don't expose it in this component, any component that relies on this component will not have access to it.
So any class that you're going to inject, that's going to be able to inject this component, you would have had added, inject, and then whatever.
Yeah.
But this is something different than that, right?
Yes.
That gives anything. So if I'm injecting an activity, that activity now has access to the application.
Yes. So if it was one layer deep. So this is why this is important. This is why everything that a module provides isn't publicly available right away. Okay, so say I have like 5 layers deep of components, right? And at the root I have application, and at the bottom that's where my injection happens, where I like inject this activity, inject that activity, inject my activity, all that stuff. Well, I don't necessarily want everything exposed in the root to be available transitively all the way down. So anything that you expose is available like 1 layer down, and then it goes away. So this will be available to components 1 layer down, will not be available to components another layer down, unless that next layer exposes it as well. I've never actually had to do that, so I'm guessing that's how it will work, but it definitely does not transitively apply. That's something I found out, and does not. So that's why there's an implementation detail. Okay, base component. This is where the component that ties in multiple modules in together, right? This is what this guy was talking about. We have our local module, our network module, and it depends on the application component. See? So modules, dependencies. Okay. So as we saw earlier, this dependency will allow this component to have access to application, right? And because this component has access to application, its modules also have access to application. Does that make sense?
So I know like local data cache takes in a context, but right here in the component it doesn't take in any context.
Well, application is context, right?
Yeah.
So
you don't have to specify it in the method get local data cache.
So you're talking about how we. Oh, you're talking about this right here?
Yeah, how like when you construct a local data cache, you need a application.
Yeah, so
context.
if you go back, whoa, this is laggy. Okay, there we go. See, provides local data cache. I provided.
Okay.
See.
So the component class doesn't need to say what.
Parameter.
Yeah, it doesn't need to say the parameter.
No. So
Okay.
so basically, when I depend on a component, all of my modules, if I'm a component, I depend on you, and you're my application component. All my modules have access to anything you expose.
Okay.
So you expose application, my modules have access to your application.
Okay.
So you're the guard to your application. I'm the guard for anything else that depends on my modules. Okay? Does that everyone get that? So let's go back to here. So as you can see, I have two components. One component, two modules, and I expose my OKHTTP, my retrofit, and my local data cache. Okay. So now we can have like a factory pattern, right, where we build out this component using the builder that gets generated, and you get OKHTTP component, get OKHTTP or get retrofit, but we're not going for that just yet. So this is what our DAG is looking like now. We have our application module, right, which provides application, which goes to this app component, right? An app component filters out what's available and provides the application to this module and this module, okay? So now these modules have access to application, and so their objects inside also have access to application, okay? Does this DAG kind of make sense to everyone? So these green boxes are arbitrary groupings. That's why that's why you never see them in actual graphs. They're just like to help you visualize things. Okay, generating files. So if you actually, when you hit build it and run or whatever, you will see that it will generate files like this: Dagger base component implements base component. This means that it will create a builder pattern, which then will allow public access to the fields that your component specified, right? So if you remember, my base component allows OKHTTP, retrofit, and local data cache. So my Dagger base component, when it gets built, it will provide those three, okay? So as you can see, and generates builders for your components. Okay, how this looks like at that, how to build stuff in this, right? So we have our application component, right? So we do Dagger application component dot builder, usual builder syntax, dot application module, new application module, okay? So something important to note is that Dagger will instantiate objects that take, like modules that have no parameters for the constructors, have default constructors. But if it's a constructor that takes a parameter, you need to provide it. So here I'm doing application module and I'm giving it directly. But if application module was a default constructor, I don't need this line. I could just do builder.build or .create, So that's something really important to know, okay? And now I have my base component. I do Dagger base component, builder, application component. I provide this application because, once again, it's a dependency for this component. And then I do .build, and there we go. Now, thanks to the magic of Dagger, we have two components, right? And both of them have everything that I need, that I provide available to them, okay? And the reason I do this at the application, because these are APIs that, for example, I want to be available throughout the app, okay? So that's the idea here. And so you can do this in multiple ways. I personally just ended up going with a private static and just doing it that way, but some people advocate against having static helper, like, right here, public static, base component, get base component, but instead of returning a static variable, having an actual instance variable and kind of like working around the lines, but I just did this for easier readability. Okay, so basically my application exposes my base component for other parts of my app. Okay, the step from factory to DI. So Dagger 2 generates complex structure behind the scenes, which also contains a factory, allowing you to do things like this, like I was talking about, factory pattern. Clean architecture application, get Tweeter API component, get Tweeter API, for example, or what have you. And in our case, that I'm showing you in my example, get base component, get OKHTTP client or whatever. So we must strive to be better. So this is kind of where I realized I forgot to add one slide. I think I deleted it by accident. But basically, the last step for you guys would be to have it where instead of having a so we have our application component, we have our base component. We would have a third component which relies on, has a dependency on the base component, which would have like inject main activity, inject some activity, right? It would be the injection component, right? I mean, it's pretty simple to understand, to grasp. It's literally give me a parameter, I will inject it for you, okay? So, but you cannot do inject object, okay? So don't just think you can be like, oh, inject object. And the reason, in case everyone's wondering, is that in annotation processors, the way it's working is it looks for every single field or method or constructor tagged with inject, and we'll figure out how to properly inject that particular object. Okay. So obviously it doesn't find one for object because object's outside of our control. So it's not going to be able to build a proper injection implementation for you. So this is now where we should be at. So what if we want to inject an activity, right? So I want to give it a Tweeter API. So in the onCreate, I do Dagger activity injector component, which is the thing I was talking about, something that injects my activities and so forth. Provide.builder, provide a Twitter component, which I get from my application, Twitter application. I kind of deleted Twitter, my Twitter API component and replaced it with base component. Keep that in mind because I made it more literal and I forgot to clean up. I'm sorry. So there's a clean architecture get base component. Okay. .build .inject this. Okay. Now you might be thinking, wait, where do we provide a Tweeter component? I mean a Tweeter API, and that's a good thought because there's something I pointed out earlier. My constructor for my Tweeter API had inject on it. So that means that it is now something that my DAG provides by, inherently. Do you guys remember that? So if you actually go to the next slide, so where does Tweeter API component come in? We have public inject, takes retrofit and cache. So now our Dagger 2 knows it can provide that to any field tagged with a Tweeter API. Does that make sense? So therefore, in this actually I didn't forget. I just realized it's up here. So as you can see, this is implementation of injection. I have at component, dependencies, base component, activity injector, void inject main activity. Okay. So this means it'll build an inject implementation for this main activity, which basically, if you guys know how injection would work, it would be like the instance of main activity dot Tweeter API is equal to factory dot get Tweeter API, because in the background it's getting off of a factory, right? Remember how I said I was one small step away from factory pattern? Well, that's what it's doing for you. It's smartly figuring out what it can provide, how it provides it, and will provide it to your method, your constructor, or your field. Okay. So that's why when you pass it this main activity, it'll literally do activity dot Tweeter API is equal to the base component dot construct the Tweeter API by doing get OKHTTP get retrofit, because remember the Tweeter API takes a retrofit, a cache, and a scheduler, which you guys don't have to worry about. So scopes. So right now I've been basically showing you guys how this dependency graph is built out and how by creating modules and having components which depend on other components, we end up building this graph which Dagger 2 instantiates objects based on their dependencies, right? I mean, I hope that all somehow sunk in. But up until this point, every single time you do an injection, it will try to provide a new instance of that object. So say my Tweeter API or my OKHTTP or my local data cache. So if you remember in my implementation of my modules, I would do return new local data cache, and pass it the application for the context, right? Or return new OKHTTP. So we're constantly instantiating new instances of variables, right? So or of new objects. So that's kind of a problem. It takes performance into consideration, and you don't have the same object going around everywhere. That's where scopes and singletons come in, right? You don't want to constantly recreate objects that you should already have access to. So this is where kind of scopes jump in. And scopes, once again, like modules, are completely arbitrary. I could call it at, blah, 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 blah. But that means that until I rebuild a component for it, it's going to provide the same, objects that when it first does a provide. Because it does lazy loading for providing. So back here, when the this implementation of my injection would happen, it would be doing main activity dot Tweeter API dot is equal to its implementation of how to get a Tweeter API, but it would always create a new one. But with scopes, it would check if it's already been created. If it's been created, return the cached implementation. Does that make sense?
So if you had 5 activities that were all injecting into the DAG, you would have, and they were all ad injecting Tweeter API.
Yeah.
You would have 5 Tweeter APIs that had been created.
Yes, because I don't have scopes, which is where this comes in. So it's very simple to make a scope. You literally do this: retention policy runtime, scope. You tag your own annotation with an annotation. The annotation is called scope, and I call it activity scope because it's supposed to be for every single life cycle of an activity. I want to create a new one of these. So that means anything in there should be recreated. It's once again, it's arbitrary. I, as the programmer, decides this. Should be recreated in the activity scope. And you could have like application scope, which is another one I make, right? So once again, these are all just singletons, and every time you do Dagger, base component .build, blah blah blah, it'll rebuild everything. But until you do that point, any scope component will retain the instantiated objects that it provides. Everyone get, yeah?
Sorry, I had a question about scope. I thought I read that you can only use it once.
So that's a good question, actually. So with scoping, the reason why scoping is important, like I said, you pointed out, you don't want 5 brand new APIs, for example, being constantly generated. Well, the folks at Google did a smart thing, and instead of because apparently back in Dagger 1 days, you just kind of tag things with @singleton everywhere. Yeah. So here they're like, all right, let's do some very literal naming. Like I said, it's arbitrary, but let's leave it to the developer to decide its scope, right? So if I have something labeled as application scope, the next component cannot be the same scope, right? So we have like application scope, we have activity scope, we have like fragment scope, custom view scope, or some arbitrary thing. I just kind of labeled out some random scopes for you, but that would be a scope. So you can have different scopes, one each layer down. So I could have my application component is my application scope. My base component is this is where the scoping thing becomes a problem. So in normal life, I would have a third module called app module and provide an application. But for the purpose of this demonstration, I had application component. So you would scope those things as application scope. Then you would have like anything that gets built out in the activity level. So maybe schedulers for some reason you want to have there. I don't know why, but just some arbitrary thing, activity scope, and so forth down the scoping level. And the way you say something is in the scope, you tag its component activity scope, for example, or they do have an @singleton, but like he said, you can only tag it once. Then you have to change the scope. What?
Bastards.
Yeah, well, it makes things more readable.
It makes sense now, but if I wanted to have this, all I had to do was create. Now I know I can create a new scope and
Yes.
name it @fuck you Google. I want another singleton scope, and that would be it would perform the same function as @singleton.
Yes, and obviously, if you listen to the way I just described things, it makes a lot of sense because for this purpose, for this demonstration, I have my app component and then I have my base component. Well, it doesn't make much sense having this 2 application scoped components. It should just be 3 modules with 1 component that's scoped at application, right? Everyone see where I'm getting at? Obviously, application should be in the same scope as application scope, right? So that's how. What's up?
I said that seems legit.
Yeah. So I mean, it's showing the logic through absurdism or whatever. Anyways, so naming your dependency. So there's situations where you have once again, which is if you go back and remember the schedulers I had in my builders, they had this named thing, this @named annotation. This is why. Because I take multiple schedulers or multiple threads or multiple objects of some name. So in this case, my class objects. I have 2 of them. Well, how does Dagger 2 distinguish between the 2, right? How it provides both? Well, it's simple. You tag them with @named, and then in your module, when you provide them, you tag the module method, @provides @named, and then you say what it's called. So in this case, I provide this one right here takes a my class 1, that one takes a my class 2. So now I have 2 of the same type of object being provided for this constructor. So does that make sense? So hopefully, as long as everyone's been kind of following me along this line, the reason for this is very clear. There's situations where you have multiple objects of the same type, but want to distinguish between them.
So that would probably be really useful if you want to inject a bunch of strings into something.
Yeah, if you want to manage your strings that way. But yeah, go ahead.
Yeah, like I'm using Realm on one project right now, and I just realized that my client's forcing me to have a separate instance so I now need 2 realms. So this would be perfect for that if I had been using.
Yeah.
Yeah.
Exactly. So you could have 2 implementations of something, or say if you're doing composition, for example, you have some interface that that has 2 different implementations that you both provide 2 of them. Well, I have my I interface and I interface 2, for example, different names, same interface, but I have 2 different implementations for it. And oh yeah, sorry, I skipped this over. Injection. This is another thing. So if I have a field or anything of that sort that's called lazy. This is kind of like a wrapper around a variable, of a type. So this lazy, my class, means that if I want to get this instance, it will delay the injection until I do my class2.get. Okay, so this is important for things that are like expensive to build. And so like if I'm doing in the onCreate, I'm doing my injection. I might not want to do a new instance of something that has to go over like 100,000 lines, right? I kind of want to do that like when someone clicks get and do a load, do all this stuff, which is where asynchronous calls come in. But once again, lazy is very important here. That's kind of what it's for. I hope lazy kind of makes sense. You shouldn't really worry yourself if you're having trouble with the concept of Dagger so far. So what is all this useful for? So that's the question people find themselves asking after their head is about to explode from their first topic of the subject matter. So testing for one. I don't know how many of you have used Makito before. So Makito is, as some of you are aware, just a framework to help instantiate mocks of objects which either stub or spy or what have you, but who cares about all that lingo? Instead of constantly doing specific implementation of mocks for my tests, I could build out, I could use the same components, but I could provide test modules. So I would have my test module extends, base module, network module, or my local test module extends local module, or application my test module extends application module, and provide these to my components, and then anything in my app that needs those will be given these mocks immediately. So it's kind of taking it out at the root of the problem. You don't have to worry about it later. It's just right off the bat. So if you have constant reuse of a mock throughout your application, you could just give it a mock, and bam, that's it. You're done. You don't have to do real network requests anymore, and you don't have to worry about constantly copy and pasting and having code redundancy. Reducing complexity and refactoring. Like in the previous example, I talked about how signatures might change for constructors and for methods. With this, you don't have to worry about it. You change it in your module, and that's it. You're done. Everything else in your consumer inside your application just takes the provided object anyways. And finally, boilerplate. So I don't know how many of you are familiar with MVP, MVVM, so forth, but very often programmers like to tightly couple their types in model view presenter or model view model, where the view model is a specific generic parameter for its for the implementation of your activity, for example. So it'd be my activity extends base view model activity and takes a type of view model, right? So it'd be tightly coupled to that. Well, a lot of times people will make this an abstract class as base view model activity, and by reflection instantiate a new instance of their view model, okay? And then there might be some setup stuff and like that. Well, with this, you can use dependency injection to give you a non-reflective instance of your view model. It will also do any type of setup that you need if you want it with your view model. So for example, give it resources or context if you want it. And there you go, boilerplate gone. I no longer have to have a abstract method for get, viewModel.class, So that removes that. And then also anything else that might pop down the line. So that's about it. That's my presentation. I hope I didn't lose everyone. So sorry if it was a little complex. I thought it would be a lot easier in my head. But any questions?
Have you tried comparing this to instead of using DI, using Gradle flavors to sort of specify, okay, here's what should be returned for this particular configuration?
So you're talking about like instead of having this whole complex Dagger object.
Yeah.
Okay. So we do use build flavors inside, for example, an isobar for our application. However, the thing is, you kind of end up as a programmer using dependency injection anyways.
Yeah, that's true.
So, like for example, you might provide some kind of manager, some data manager to your view models or something like this, right? And the problem is you kind of have to think about it as you implement it. With this, once you do this boilerplate of setting up your components and your modules, you pretty much just arbitrarily add things to the right scope, and then anything else gets it automatically. So you don't have to be like, oh, suddenly I need this in my project like 2 months in, and then I have to change my implementations and then refactor. I literally add inject and then implementation in the module, and I'm done. That's maybe 20 minutes of work.
Yeah.
So that's what I'm getting at. I hope I got your question. Maybe I didn't. I might be missing what you're trying to
Yeah, no,
ask.
I'll talk to you a little bit about it afterwards. I can give you a code example. But basically, I've seen some of the stuff that I've worked on sort of essentially winds up using, it's a little, again, square peg in a round hole, but it winds up using Gradle flavors to be able to say, like, okay, like each of these flavors has a version of this file. So like this version has a version that hits our staging server. This version has a version that hits our prod server.
Yeah.
This has a version that just returns the mock data.
Yeah, I know what you're talking about then, I think. So you're basically saying like when you're instantiating, like using maybe a factory pattern or something like that, you go off your Gradle and you get current pointed to server or whatever.
Yeah, basically like you would get your own like API thing and it would like get API and it would return whatever.
Yeah, it would be based off of whatever your flavor currently is. Yeah, we do that for our servers right now, like what we're hitting, where it's staging, production or beta or in the background. Currently in development. I forget the name for it. But anyways, we have like 7 different ones. But the idea of dependency injection is less about like maybe like she said, hitting a certain API. It's more about getting what you need at any point once you do this boilerplate. So, for example, I was very apprehensive about this when I first started. I was like, oh my god, I hate my life as I tried to figure this out. But then once you do this boilerplate, the rest of your application is smooth sailing. You need something, you get something. Very simple mantra. Yeah.
So it's like, or I can imagine it being useful. It's like you have an activity or a fragment that you think you're just going to need. Well, never mind, I think about that example.
Here's a good example. Something that I messed up on originally in my implementation. When I'm going to point you guys to a repo that shows all this code and it's more up to date. Basically, as I was developing it, before I did my test suite, I was not caring so much about my schedulers. I just kind of was doing Android, schedulers main thread, and just for RxJava, for those of you who are familiar. And basically what was happening was, and when I was trying to do my JVM tests instead of Android tests, it was like, hey, what are you talking about, bro? So now, using my dependency injection, I provide the current main scheduler, so for like, UI level things. So then in my tests, all I do is I do a fake, a mock thread module, and instead of doing Android schedulers.main thread or whatever, I do schedulers.new thread or whatever. And so now this means that for my tests, it doesn't care about the Android thread or what have you. It just works. It just, so any dependency later down, my presenters or my view models and so forth, they get that scheduler automatically. So depending on if I'm in development or if I'm in my tests. And yeah, I hope. Sorry for being a little all over the place, guys. I hope I did a good job.
No, good.
Yeah.
It's a complex topic.
I feel like I understood it better than what Jake Gordon explained.
Oh, I'll take that. What's up?
I have a question about the lazy loading injection.
Yes.
Does it can happen on background thread?
Yeah, so there was actually a topic in Reddit Android Dev a few weeks ago where someone was talking about asynchronous instantiation of objects. So it basically comes down to the way you want to have it in your provides, right? So with this lazy, I haven't checked the documentation lately, but I don't believe it happens in the background thread. It just happens at a later point in time, like lazy.
So whenever thread is executing,
Yes.
inject.
Yeah. So therefore, in your
So you can start new thread and then
yes.
run the lazy injector.
Yeah, in your provides.
Right,
Yes.
but of course some components may require to be constructed on UI thread.
Yes.
So that's
Yeah. So that's why you kind of want to like in certain situations you might want to do lazy, right? So when it's lazily being loaded in, there's a few ways to do it. I've never actually personally messed around too much with asynchronous load, dependency injection. But there are ways. I'm sure if you get, if you're getting into the point where you want to look up asynchronous creation of objects and dependency injection, you're probably at a point where you no longer need these slides. You could just Google around and figure it out on your own. But up until that point, if I remember correctly, lazy does not do it on this background thread. But I could be mistaken on this. I mean, lazy is lazy, right? I mean, I do it. I've done it a few times. Usually, when an actual implementation for lazy is I might have like a utility object or something like this in my base class that I don't always want to instantiate or whatever in my scopes. So I do a lazy, and then if my current subclass needs it, it just gets it and it has it. Otherwise, it just never gets actually loaded in. So that's a very good example for lazy, in my opinion. I hope that answered your question.
probably maybe also inject observable.
Yeah, exactly. Yeah, that's another way. Yeah, that's the way that Jake Warren was talking about with this one guy. You provide an observable, and you just kind of run it when you. Yeah. So any other questions? Did I hope any small questions or anything like that? Nope.
Sorry, another question. I just want to. I was really frustrated the first time I tried to implement Dagger 2, only because so a lot of this stuff is generated when you build it. So
Yes.
like that Dagger app component, Dagger whatever component thing, where you start it off in whatever activity or fragment or view that you're using. So you need to hit build, otherwise it can't find it.
Yeah, so that's actually where annotation processors come in, right? I don't have a talk for it this time, and I'm sure your heads are about to explode anyways. Otherwise, I would dive into that as well. But yes, annotation processors are a beast in itself. So the stuff they're doing in the background is actually pretty amazing. If you actually try building an annotation processor on your free time, you'll realize that what they wrote is no joke. But yes, you do have to rebuild every single time you do a change inside, your Dagger, your DAG. So keep that in mind.
If you clean, suddenly everything will break.
Yeah, it'll give you a ton of errors.
Yeah. So if you clean, rebuild.
Yeah. So if you actually use the new data binding library, for example, that's also based off annotation processors. So if you clean, your view bindings are gone. It's like, hey, my view bindings are gone, great, but really you just have to rebuild. So anything with annotations and generated files needs to be rebuilt. Okay, thank you for having me.